Let's look at one more component of methods, and those are static methods. And static methods are methods that are set up in a way that you'll call them directly on the class name without having to instantiate an object. So the first thing we want to do is look at the math methods. The math methods are all static methods where you'll call them directly on the math class, and they perform some kind of mathematical operation for you. Here we have floor, which rounds down, ceiling that rounds up, powers, x to the power of y, absolute value, square root. You kind of get the idea of looking at this chart, how the rest of these work. Round, min, and max, and random. Random we're going to use quite a bit. We're going to do some graphical stuff throughout the year where we need to generate random values, and there'll be some other places for that too. And some of these other methods we'll use off and on, but these are methods that you need to be aware of, and they are static methods that you'll call directly on the math class, and they're also all return methods. So in this example, I made a scanner, I made a variable num, and I said keyboard get me the next double. And notice we're calling a method on a reference. Keyboard's a reference. Next double is a method, just kind of tie in the stuff that we've been talking about so far. And then in the print line, we have math.ceiling num. Notice nowhere in here did I say math m equals new math. We didn't do any of that. We're calling the ceiling directly on the math class because the ceil method is a static method that's attached to the class that way. So if we pass in 3.45, it rounds it up. The ceiling's above you. You know, I go over this all the time in class, and people get confused about ceiling and floor. It's not really that complicated. The ceiling's above you, the floor is below you. One rounds up, one rounds down. You know, you can kind of fill in the blanks. So here's some more examples. I'm calling floor, ceiling, power, absolute value, and square root. The main thing about this is, yes, they're math methods, but they're also static. The methods are being called directly on the class name. The name of the class where these methods live is the math class. And here are just some more examples so you can see the basic idea of these. The past slide and this one is just so you can see these math methods in action to make sure that you truly understand what min does, max, square root, and round. And here's random. Random generates a number between 0.0 and 1.0 exclusive of 1.0. So you're basically going to take that value at some point and multiply it times some whole numbers, create some ranges. We're going to do a whole lot of stuff with it throughout the year, but the basic idea is it returns a fractional value that you can then use to create other values. And in this case, I'm multiplying random times 10. So I'm multiplying a value between 0.0 and 1.0 exclusive of 1.0 times 10, meaning the range of values I could get would be 0.0 to 9.999. You get the idea. So if I take the 0.0 to 9 point something fractional value and I cast that to an integer, and we talked about casting in the last unit, it lops off all the decimal places and I'm just left with the whole number component. So the random method is a math method, but understand too that all the math methods are static, and this is one that we're going to use off and on throughout the year, so you're going to just need to make sure you dig in and spend some time messing around with it. So here's actually how you set up a method and make it static. So here I have class fun2. Inside I took the times method that we were just looking at. I just added the word static on the front and turned it in front of the return type. That means that method now is bound to the class, and whenever I want to use it, I don't have to instantiate an object. I can just call it directly on the actual class name. So in this example, I got another picture of the method, and then I show you the code. I'm printing it out by doing fun2.times, which is exactly what we were doing with the math methods before. Over there we had math.power, math.round, math.ceiling, whatever the case may be. And here, instead of using math, I'm using fun2 because the times lives inside of the fun2 class and it's defined as static. Static methods can be called directly on the class name, which is what we're looking at. You could also call them with an object instantiation if you wanted to, but all the math methods are static because they work the same way as the fun2 example that we were just looking at. So before we had fun2 times times, now we have math.floor, math.ceiling, math.power, and this is just another example of the same scenario, except showing you that you could call it on an object instantiation if you want, but the benefit of the static piece is that you can call it directly on the class name if that's what you want to do. So let's go out and let's take a look at some code. We've got a lot of different stuff to look at after going through this chunk of slides. Let's take a look at some static method examples. And this one that we're looking at right now, we have lots of examples of the math methods being used. Anytime you want to call the math method, you must call it on capital M, math, because that is the name of the class where these methods are defined as static methods. So Here we have a whole bunch of the methods being used. What you need to do is open up one of these examples, obviously this one, and change the numbers and change the values and keep running these methods until you make for sure, or you're for certain that you understand exactly how each of them works. And that shouldn't take that long. So in the first one, I've got floor 3.94. Let's change that to 3.14, and we'll run it again and notice that you still get 3.0. So if we change it to 3.99, still going to get 3.0. Several of the math methods return, or most of the math methods return decimals, return doubles. Round returns an int, and max and min will return ints or doubles depending on what you're trying to do. So just as an example, if I have max of 5.7, it's going to return 7.0, because anytime one part of it is a double, that means it's going to return a double. That's just how that works. There's way more to it than we have time to discuss. But anyway, go back through these examples, change the values, and make sure that you understand how all these methods work, and remember that they're all static and they're called directly on the math class. So let's look at Fun2 and Fun2 Runner. In Fun2 Runner, I'm calling the times method from the Fun2 class in the same way that I called the math methods. The name of the class where times is defined as static is Fun2. So I do Fun2.times and pass in whatever actual parameters I want to process inside of the actual times method. So notice in Fun2, the method times is defined as static, so that whenever you use it, you have the option of instantiating an object, which we're not going to do, or run it directly on the class. So when I run this, I get 42, 33, 8, and 861. That's because of the values that I'm passing in. 6 times 7 is 42, 3 times 11 is 33, and so on. So if I was to go into the class and take the word static off and go back to the runner and try to run it again, now I have an issue. Because the method's not static, I cannot call it directly on the class name. The only way I can call it directly on the class name is if I have defined it as a static method. That is the only way that will let you do that. So if you take that static off and you try to run it again, we have an issue. So if you're trying to make a static method and you forget to put static on there, obviously that's going to be an issue. So if you use the math methods example and you change up your values and then you go and back and forth with Fun2 and Fun2 Runner, you should be able to use these examples to make sure that you 100% understand how all this works.